Chapter 2.4, exercise 7 through 10, 13 through 16, and 19 through 22. This is a section that has to do with synthetic and long division of polynomials, and also we're getting to the remainder theorem here. In exercise 7 through 10, divide using synthetic division and write a summary statement in fraction form. Well, here, what we have is we're going to divide this x cubed minus 5x squared plus 3x minus 2 by the linear binomial x plus 1. And to find out what we use in synthetic division, we take this x plus 1 and set this equal to 0 to find our 0. As we solve for x is equal to negative 1. So that is our 0. And so in devising our synthetic division bracket, we're going to put negative 1 outside here, and then the coefficients of the dividend above. So we have 1x cubed minus 5x squared plus 3x minus 2. We got to make sure we're in standard form where we have the coefficients, the powered coefficients in order from highest to least, which we do have here. So the first thing we do is bring down the 1, which is in our x squared's place. And then negative 1 times 1 is negative 1. Negative 5 plus negative 1 is negative 6. Negative 1 times negative 6 is what? 6. 3 plus 6 is 9. Negative 1 times 9 is negative 9. And then we add our remainder column here, which is negative 11. And so our answer is going to be, and the way they have the book for just the summary statement is this function here equals, in fact, to get our summary statement, I'm just going to relocate all this stuff here. Let's see. There we do. Let's relocate all this here. So for the summary statement, I'm going to put x squared minus 6x plus 9 minus 11 over our divisor, which is x plus 1. So that's going to be, we have the x squared place, x squared minus 6x plus 9 minus 11 over our divisor. So this will be our answer for problem number 7. Next on our problem, which is 9, we have 9x cubed plus 7x squared minus 3x. And I'm going to also add plus 0. Why? Because we need to have the x to the 0 powered place represented. So we're going to have the same thing we had before, which is we have x minus 10 is equal to 0. So therefore, our x here, x equals 10. So we take our synthetic division bracket here and put 10 on the outside, and then our coefficients, which are going to be 9 for 9x cubed, 7x squared, minus 3 for 3x, and 0. And then we bring down the 9 into the x squared's place. So we have 9. 10 times 9, 90. 90 plus 7, 97. That's our x's place. 10 times 97 is 970. We see this get out of control. And then we have negative 3 plus 970. That's going to be 967. And 10 times 967 is 9,670. And we bring down what we have left, which is in our remainder place, 9,670. So we're going to have 9x squared plus 97x plus 967 plus 9,670 over x minus 10. And we're going to write our summary statement up here at the top. So same thing, 9x squared plus 97x plus 967 plus 9,670 over our divisor, which is x minus 10. So that would be our summary statement, and this we box in as our correct answer. Next, odd number problem, which is 13. In exercise 13-16, use the remainder theorem to find the remainder when f of x is divided by x minus k. So in this case, we would have our divisor would be x minus 2. All right, that's what we're dividing by when we say this. So it's like dividing f of x by x minus 2. So the remainder theorem, what we need to do is plug in the value of k anywhere we see the x to find our remainder. So we're going to plug this in for x here. We're going to plug 2 in for x here. So our remainder equals 2 times 2 squared minus 3 times 2 plus 1. And working this out, we have 2 squared is 4, 2 times 4 is 8, minus 3 times 2 minus 6 plus 1. And 8 minus 6 is 2 plus 1 is 3. So remainder, our summary statement, the remainder is equal to 3 over our divisor, which is x minus 2, which is x minus k. So that's going to be it. And if we use synthetic division, we will see the same thing. So we're going to put 2, I'm doing this real quick here, x squared, 2x squared minus 3 plus 1. So we bring down the 2. So we're going to have 2x, 2 times 2 is 4. That's going to be 1. 2 times 1 is 2. So 3. So our remainder is in fact the same thing as 3 here. So that's going to be it. Next. And the purpose being that we don't have to find a remainder. We don't have to go through all the process of synthetic division or long division to find that out using the remainder theorem. Here we have, use the remainder theorem. So we're going to have our divisor here is going to be, it's going to be x minus k. So x minus negative 3, which equals x plus 3. So that's going to be our divisor. And so remainder, what is our remainder going to be? Well, it's going to be, we plug in our negative 3, k, so we have negative 3 cubed minus negative 3 squared plus 2 times negative 3, okay, and then plus 1. And so negative 3 cubed is negative 27. Negative 3 times negative 3 is 9. Okay, minus, we're going to have minus 3 squared, which is minus 9. And we're going to have plus 2 times negative 3. That's going to be minus 6 plus 1. So negative 27 minus 9 is going to be negative 36 minus 6 plus 1. And negative 36 minus 6, that's going to be negative 42 plus 1. which equals negative 41. So our remainder is going to be this negative 41 divided by our divisor, which is going to be x plus 3. So that will be our statement with the remainder in that form. Next, we have in exercises 19 through 22, use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. And so we have our divisor is this thing right here, right? X, and so it's going to be in the form x minus k. Well, for this, for x minus 1, k is equal to what? 1. And so we're going to plug in 1 for k. And so using the factor theorem, which is really the same as the remainder theorem, except you're just trying to get a different conclusion. The remainder theorem is used to find what the remainder is, but the factor theorem is using the same thing, but determine whether whether in this case x minus 1 is a factor. What we do is we plug in. So we're going to plug in 1 cubed, right? Plug in 1 right here. So we plug this in 3 places. The cubed place, the squared place, and the x place. So we have 1 cubed minus 1 squared plus 1 minus 1. So in this case we have 1 minus 1 plus 1 minus 1. See, they all cancel out, so we have equal to 0. So we conclude, therefore, x minus 1 is a factor of x cubed minus x squared plus x minus 1. So we know it's a factor, so we can go ahead and divide out and further factor this cubic polynomial. Next, last number problem, which is 21, use a factor theorem to determine whether the first polynomial is a factor of the second polynomial. Here, if we have x minus k, right, so in this case k is equal to 2. And so if we plug in 2, we get 2 cubed plus 3 times 2 minus 4. So we have 8 plus 6 minus 4, which equals 14 minus 4, which equals 10. Okay, so in this case, remainder is not equal to 0. Therefore, x minus 2 is not a factor of x cubed plus 3x minus 4. So we could try different values of k. We could try negative 2. We could try positive 1, negative 1. So that is our answer. I'll just don't box this whole thing in. So anyway, go ahead and work out your even number problems as a demonstration of your learning. And I thank you for viewing. Bye-bye now.